A few months ago, I fired up SWE-1 on Windsurf and found it was ambitious. It was exciting to see a dedicated model for coding, and it did a decent job with the prompt we gave it. However, it lacked a bit in the speed compared to other models, didn't quite implement a fully working solution, and produced code that needed further security investigation. Fast forward to today, and we've got SWE 1.5. According to Windsurf, it delivers near SOTA coding performance at unprecedented speed. What does SOTA mean? Apparently, SOTA stands for state of the art. So now you know, Snyk. In this video, I'll be revisiting the same prompt and workflow I used last time, comparing SWE1 with 1.5. We'll find out if they fixed the slow speed, are the UIs more complete and fully functional, have they cleaned up or minimized the code security issues. Sit tight because we're gonna put SWE 1.5 to the test now. All right, as usual, to keep things fair, we're gonna give it a very abbreviated, simple, vibe-coded prompt like we've been doing with other models and send it off to Windsurf's SWE 1.5 model now. Okay, right off the bat, this does feel way faster than before. We already have a package.json git ignore env example. It started with its to-do list here. It's working on the first to-do item setup project structure with package.json and security-focused dependencies. So it analyzed that prompt very quickly and came up with a task list to fulfill that prompt and started implementing each task right now. It's working on task 1, which is in progress, showing me the status of that right here in Cascade on Windsurf. Looks like 1 of 8 is done task right there, and it's working on 2. Oh, 2 is done, 3 is done. Just in that explaining, we got 5 out of 8 tasks done already, even more. As I'm speaking, 7 out of 8. So we got 1 more to go, and then I think it's going to be done. This will be indeed fulfilling their promise of speeding up the model. It's super fast this time around. And I'm noticing this trend with other tools and models that are out there. We want to get to a point where this workflow, when we as developers are using AI to assist us in ways of writing code, generating code, and helping us in these projects, that cycle, that loop that we're going through needs to be quick and tight, so that we're not sitting here waiting for so long. In fact, in the last video, the editing team made fun of me kind of falling asleep while the model was working on the prompt. In this case, I had no time to take a nap. All right, looks like it's done. I'm gonna click accept all and review the results. I'm not going to bore you with the details of going on here, but it looks like it's following a lot of the standard best practices for security implementations that you would expect in a project like this. The folder structure is like that. And then if we want to get set up, we're going to run npm install. So I'll go do that now, see if I can run right out of the box without me changing anything other than following these simple setup instructions. All right, we're back. I did everything it instructed me to do to get things set up with npm installing and making environment variables that we needed, and ran it with npm start dev for this case. And this is the results. Now, we didn't tell it to make it pretty, okay, folks? It is working and running, and I'm able to access it now without significant issues of being able to at least get started. But yeah, it is not exactly the best looking app that we've seen here, but that's okay. That's something we can iterate on with the model to improve the style of it. We right now just want something functioning that is secure. Now, it's a little bit, hard to follow along with what's going on here. And I think as a result of some of the security features it put in place, yes, it's having issues rendering the page in a way that it would expect to, because of things like X-frame options may only be set via HTTP header sent along with the document. So we can look into that here. So it's trying to use meta HTML tags to do X-frame options when that should be best served via an HTTP header. And then some of the things, loading style sheets from external resources, which a little bit of a risk. I mean, Cloudflare is generally good CDN.js, good CDN to load resources for web applications. In this case, we're looking at Font Awesome and Tailwind that are resources that it's trying to load externally, but didn't quite get the content security policy directives set up in a way to enable the browser to load these resources. So this is a good thing that the browser is blocking it based on the content security policy that Windsurf's SWE 1.5 model put in place. So that's like a positive thing. And it's also a validating thing for us as developers that content security policies, getting those right is extremely hard and challenging, and even models are struggling with it, as we can see here. So that said, I'm noticing this trend with the models, any other models recently as well, where they're putting in a content security policy, but they're not quite getting the content security policy defined in a way that enables it to use the resources that it wants to properly. So we run into these issues. So that's something that I can address separately on my own, either manually or working with the model to iterate on the content security policy to get this right for the purposes of this. So I think for the most part, this, I don't know what this button necessarily is doing. We'll see if we can create a note. Let's say test note 1. This is a note. And if we save it, okay, that worked. It saved it. It kind of has some styling around it where it's like a card looking thing with the little drop shadow background. So it's getting there. It's doing pretty good. And the key thing here, I gotta say, it was crazy fast. So that is definitely a huge improvement. And the amount of code it produced in such a short period of time was pretty impressive. And it looks decent from what I've seen so far. Let's jump into that really quick too. All right, looking at the project structure here, it's following a lot of common patterns and practices with a Node.js based application like this, using middleware folder where it has error handling, sanitization, validation going on. So good to see that type of stuff from a security standpoint. The models being defined, we have a note, we have some public resources, static assets that are going to be hosted on the UI side of things, and then some routes as well, like the notes, CRUD, create, read, update, delete routes that we have for that. Some tests even, and some scripts, security monitor script, which is the first I've seen something like this going on here, which is quite interesting. And what that does, really quick to show you how SWE 1.5 approached this. If we look at the security check script, it runs npm audit, which is built in with npm, lint, and then it runs this script, security monitor JS. And if we look at the contents of that script, we'll see that it's essentially built out the code to log things that it detects to be kind of a security alert, essentially. So this is the first I've seen a model do this. I'm intrigued by that. It's interesting. I don't know how well this works in practice, but I like the idea. It's creative. You know, it's a cool thing to see. So it will log things like SQL injection attempts, cross-site scripting, cross-site request forgery attempts, stuff like that. Or if somebody's trying to inject certain script text, JavaScript text, that type of thing. Super interesting to see that. Now, is this necessarily a robust solution? No, but it's an indication of some creative problem solving from a security standpoint. So I think of this as a positive thing, and it's a cool idea to at least give me ideas of potential things that we can do in this project. So last but not least, we have the server that runs everything and gets it all. This is fairly standard stuff that you see with typical Node applications and very similar dependencies that we're leaning on here. From a code standpoint and security standpoint of how it implemented the code, let's take a look at one of the routes, the notes routes. So let's take a look at this post route where it's going to create a new note. In it, it has some middleware functions like sanitize body and validate note, which is nice to see. So let's take a look at what's happening in that middleware function. It's checking to make sure there's a request body. It's looking for a title for the note, content for the note, and any tags that might be associated with it. And in each of those, it's got a separate function to sanitize the title as a string, the content as HTML, which is kind of odd. I don't know that we would want the content of a note to be HTML. It should just be text as well, like a string, but okay. And then tags would be an array of, I assume, strings as well. So let's take a look at what it's doing for sanitize the string. It's making sure it is a type of string. It's looking for script tags, a JavaScript protocol being included in the string, or someone trying to inject cross-site scripting via the on event handlers for HTML elements. So this is nice to see. However, I don't know if this is the most robust solution to help sanitize strings from these types of attacks. I would have preferred it to lean on something tried and true and thoroughly tested third-party NPM package potentially that's widely used and available for us in these types of applications instead of writing its own. But it's nice to see that it's at least attempting to do so and should stop a lot of the common approaches to such an attack. Sanitize arrays, just making sure it's an array and then checking that the contents of each item in the array is sanitized strings. That's nice to see. And then when it comes to sanitize HTML, it's using DOM Purify, and then we have the ability to choose what allowed tags or attributes we want to enable for the content of anything within HTML. I'm interested in understanding why it made that decision to have the notes description be HTML, but in the case that it's approaching it this way, it's at least a little bit comforting knowing that it's putting some added sanitization on top of that using a widely known library in the community called DOM Purify. All right, that was a brief overview of the code. That said, let's take a look at what Snyk detects using the Snyk extension in Windsurf. When we run the scan for everything, see if we have any security issues both in the dependencies and the code that it wrote. So first up, we have open source security, which is the dependencies that Windsurf SWE 1.5 chose to use for this project. And it looks like we have one medium severity issue with this cookie dependency. This is common with any of the models that are leaning on the CSRF NPM package to address cross-site request forgery mitigation. So not a huge ding against the security of the dependencies that SWE 1.5 chose here, because it's a common thing that the models are struggling with. I would like to see it use newer packages that are available to address that need in the project instead of the CSRF module. So all that is a little bit of a step backwards for this model, because the last model didn't have any NPM package concerns with security. It's not really a huge concern. It's something that can be addressed fairly simply. That said, the code security scan shows a significant reduction in the vulnerabilities that it found there and in the severity of the vulnerabilities that it found. So we have 4 issues in total, 2 of them being medium within this app.js file within the public static assets of the application, and then 2 medium severity in the notes routes. So let's take a look at this one on the front end of it. We have a DOM-based cross-site scripting issue in here. And actually, let's look at this here. So Snyk is alerting us to this to double check and dig into further for a possible DOM-based cross-site scripting vulnerability in here, because we're signing HTML into the inner HTML of this element on the page in the browser. And as a result of that, the text that's being used within here is injecting user-defined data like note.id and the tags. Now, one thing to note here is that it is attempting to escape at least the content of it and the title here, but in this situation, it is not when it comes to assigning that to the event handler here. So could be a potential issue we'd need to dig into further and test out as well to understand the implications of this potential vulnerability here. So that's just one example of that. Then we have prototype pollution potentially on the server side in the update function for the note model when updating it based on the note ID and the body of the request coming in there. So to me, this seems like a significant improvement from SWE 1.0. As with the other models that we've tried in the past, things are improving and starting to flatten out in the sense of how they're approaching solving this prompt that we keep giving it. And it's nice to see such a significant progress with Windsurf's SWE model that also is super fast and snappy, which keeps us moving as developers in that workflow more quickly, more rapidly, and iterating on our project. All that said, Windsurf's SWE 1.5 model could be improved even further from a security perspective with the likes of Snyk Studio, which offers an MCP server that can help guide the model to reduce the code security issues even further and the open source dependencies further. If you're interested in something like that, let me know in the comments below and we can look into making a video to cover that further. That does it for this video. If you got value out of it, be sure to like it down below and share with somebody who could put it to use. And if you made it this far, subscribe to the channel so you don't miss out on upcoming videos. Thanks for watching and happy, safe coding, everyone.